Hi everyone, my name is Victor and my presentation is One for All and All for One, which is also the motto of Switzerland. I will be talking about the competitive dynamics of social processes. First of all, I wanted to wish you a very warm welcome to hell. You are the beginning of a very long journey, and you might have seen this plot already. It's from PhD Comics, and it describes the journey of a grad student. You might be here right now, blessed with blissful optimism. But a PhD is a journey during which you will be challenged. You will be challenged to find a thesis project. You will also be challenged by the difficult questions and the difficult problems you will have to solve. You will also be frustrated. You will be frustrated by equations that you cannot solve. You will be frustrated by theorems that you cannot prove and by code that doesn't run. You will also be anxious. You will be anxious about your projects not making any progress for the first few weeks or months or even years. And you will be anxious about your publication not being accepted. And finally, you will also feel lonely. You will feel lonely because you will be working alone on a very difficult problem that most likely you will be the only one trying to tackle in the world at this current time. So given the fact that your journey will be long and difficult, why not come to a place where it is great to have a difficult time? EPFL campus is really beautiful, as you can see on this picture. This campus is also very dynamic. There is a great social life with many associations and concerts happening. It is the infrastructure is great, and the city of Lausanne is a super peaceful one. The nightlife is amazing. You have great outdoor activities, and Switzerland is a beautiful country where you will most likely learn how to ski. It's also a journey during which you will solve important questions and you will become the expert in your own very specific domain. During a PhD, you will also advance human knowledge and you will push the frontiers of what we know and building on the shoulders of your peers. It's also a journey during which you will be able to publish your work and to contribute to your community and to feel that you are part of a community of other people working on similar projects. Finally, and most importantly, it's also a journey during which you will make amazing friends. In my case, I'm rather at the end of my journey, and I have decided to study the competitive dynamics of social processes. The research question I try to answer is, how do people interact? And to answer these questions, I took the angle of studying how people tend to cooperate and how they compete against each other. And of course, I've looked at the dynamics of these two aspects of human behavior. While doing so, I tried to develop new models and algorithms, drawing from discrete choice models and from latent factor models. And I focused on several different applications, ranging from Wikipedia to sports, to the climate, and to politics. And in the rest of this talk, I will try to focus on, I will give you two examples of applications in sports and in politics. For sports, let's start with tennis. And given a data set of tennis matches between two players and the final outcome at a given date, I was interested in answering questions such as, how strong was Roger Federer in 2006? Or how likely is Nadal to beat Novak Djokovic in the next game? The model we propose is formulated like this, where we can read that the probability of player I winning over player J at a given time t is a function of the difference between the skill of player I at time t and the skill of player J at time t. And this function, you might have recognized it, is called the sigmoid function. A further assumption that we make is that each skill of the players is a Gaussian process with a given covariance function, which enables us to encode the time dynamics. The model is flexible and it's powerful. We could beat several different baselines on many different data sets. And it also enables us to gain some insightful interpretation in terms of the evolution of the skill of different players. And here I show you 6 different players, and you can follow the path of their career over time. We also use this model to make predictions for football matches or soccer matches. And we publish that in a web platform called Kickoff AI, which provides predictions for upcoming matches in the top 5 European leagues. Next, I was interested in understanding how people vote, and in particular in Switzerland. You will know, and you should know, that in Switzerland, the citizens vote on referenda 4 times a year. So given the data sets of municipalities and referenda, where each entry in this matrix is the percentage of yes that a particular municipality has voted for a particular referendum. We start by decomposing this result matrix as the product of 2 Laurent matrices. And to do so, we use the very famous technique called singular value decomposition. These 2 matrices contain representations of the municipalities and representations of the referenda. And we can reproduce each entry of the results matrix by multiplying the corresponding row and the corresponding column of those representation matrices. Now, let's say we have a new column in the result matrix corresponding to a new referendum, and we would like to make prediction on this for this referendum. Of course, this means that we will need a new representation vector for this current referendum. Let's further assume that we can observe a few results of this referendum, and we would like to make predictions on the unobserved ones. To do so, we will use the representation of the municipalities for which we do have results, together with the results, in order to approximate this representation of the referendum. And this approximation will be obtained by a generalized linear model. Now we can use the representation of the municipalities for which we don't have a result, together with the approximation of the referendum vector, in order to obtain predictions for the missing entries. In our experiment, we were able, and on real data, to obtain very accurate predictions very early on, with using only a few municipal results. Further, we could also have a look at municipalities representation, which means that we will be using this matrix here to try to interpret what information is contained in the result matrix. So we will plot the first 2 entries of this representation matrix for the municipalities and project that onto a 2-dimensional plane where every dot is a municipality. And we can already see at least 2 distinct clusters. By coloring these clusters with the language spoken in each of these municipalities, we obtain very clearly 3 different clusters corresponding to the French-speaking municipalities, the Italian-speaking municipalities, and the German-speaking ones. Further, we also see that there is a separation between the French-speaking municipalities and the rest. And this exhibits what we call the Röstigraben, or the border of the Rösti, where Rösti is a typical dish in the German-speaking part of Switzerland. And this exhibits the cultural differences that exist between different regions in Switzerland. We can also see that at the top of each cluster, we find cities of Geneva, Lausanne, Zurich, Basel, and Bern that are all big cities and progressive regions of Switzerland. Whereas at the bottom of each cluster, we find municipalities from the countryside and from in the mountains that are rather conservative. We also developed a web platform to provide real-time predictions of Swiss votes, and this is available on predigon.ch. Finally, in my most recent piece of work is about how people make laws. And this is what I described. This is a project that I described in my poster, so you can check it out in this Pocket Campus app. And voila, thank you very much for your attention, and I wish you a very safe journey. If you have questions, don't hesitate to reach out to me to my email address.